Hello, good morning. I'm discussing about nanolithography. Nanolithography is the branch of nanotechnology dealing with the study and implementation of nanofabrication of nanometer scale structures, which means nanopatterning with at least one lateral dimension between the size of an individual atom in about 100 nanometer. Nanolithography techniques are following: photolithography, electron beam lithography, X-ray lithography, extreme ultraviolet lithography, light coupling nanolithography, scanning probe microscope lithography, nano imprint lithography, deep pen lithography. First of all, photolithography. Photolithography is the techniques used in the nanolithography are quite similar to those used in conventional lithography for image and printing output. Photolithography is widely used to manufacture computer chips. This method permits hundreds of chips to be produced on a single silicon wafer at the same time. Photolithography can create the features as small as 50 nanometers in the mass manufacture of microelectronics and semiconductor device. Photolithography is the most widely utilized process. It is distinguished by high production throughput as well as small size pattern features. Electron beam lithography. Electron beam lithography etching a pattern of nano-sized features by scanning a closely focused beam of electrons across the surface of the substrate. Electron beam lithography can create features as the 20 nanometer, but it is both expensive and time demanding. A lithographic procedure that would take 5 minutes with photolithography would take around 5 hours with electron beam lithography. X-ray lithography. X-ray lithography is similar to photolithography and extreme ultraviolet lithography, except it employs a mask constructed of an X-ray transparent material with a pattern of high atomic number, either etched or deposited on it. A parallel beam of X-rays is used to expose the substrate resist. The edge pattern resolution is determined by the mass characteristics and the exposure control. Extreme ultraviolet lithography. Extreme ultraviolet lithography is similar to regular photolithography in that it burns a pattern into a silicon wafer using intense beams of ultraviolet light reflected from a circuit design pattern. Unlike the photolithography, which employs a lens system to concentrate light, extreme ultraviolet light is reflected through a sequence of mirrors in extreme ultraviolet lithography. The current limiting issue in extreme ultraviolet lithography is the ability to build mirrors with adequate precision, but if this problem is overcome, resolution below 30 nanometer are expected. Light coupling nanolithography. Another version on photography is the light coupling nanolithography. A polymer mask is placed in contact with the photoresist in light coupling nanolithography. Where exposure is required, transparent paths protrude through the topographically designed mask. The contrast of mask areas can be improved further by applying a thin gold overlay. Scanning probe microscope lithography. The electric field at the tip of the scanning probe microscope is used lithography to oxidize materials in specified pattern. After that, the oxidized pattern can be removed by a preferred etching. Nano-imprint lithography. Nano-imprint lithography is a simple procedure that embosses the resist with the desired design using the mold. After embossing, the compressed resist material is removed with anisotropic etching, exposing the substrate. Nano-imprint lithography can achieve solution of less than 10 nanometer while maintaining the high throughput and cheap cost. The development of the mold itself is the present obstacle to production at this resolution. Self-assembly manufacturing may hold the key to overcoming this barrier. Deep pen nanolithography. Deep pen nanolithography is the direct lithography process that can write that builds a pattern on the substrate material rather than etching it away using the atomic force microscope. Similarly to how a traditional dip pen takes off ink from an ink wall and then writes on paper, molecules are picked up from the reservoir on the end of the atomic force microscope tip and deposited on the surface of the substrate via the solvent or water. Deep pen nanolithography can produce patterns with the resolution as low 40 nanometers. Okay, it's all about nanolithography. Thanks for watching. Thank you for the lesson. That's now. Bye bye. See you again.